Starting time and leaving time, and what is the last practical?
Flow cytometry.
Flow cytometry. Very good. Then let us see your actual syllabus practicals. Yesterday I already had actually this discussion. So the first practical was parts of microscope. Then second practical was centrifuge. Then third practical cleaning and cleaning of glassware. Next one, fourth practical anticoagulants preparation. Then fifth one, collection of
Venous blood.
okay, phlebotomy. Then sixth one,
Cleaning of glass cages.
okay, cylinders. Actually, this is cleaning of cylinders. Okay, of cylinders. Then
Preparation of stain and other reagents.
preparation of staining and reagents in hematology lab. Okay. Preparation of stains. Okay. Next one is practical.
PBS.
PBS. Then 9 practical.
Staining of PBS.
Staining of PBS. Okay. Staining of PBS. Okay. Staining of peripheral blood smear, and last and final practical was
Actually estimation.
XP estimation. So what was your thoughts on syllabus coverage? Do we cover all the syllabus or not?
Yes.
We right? So please don't blame me that I didn't discuss about cleaning of glassware, these things, okay? Preparation of stains, we already discussed one important stain. What is that? Leishman stain. So what are the ingredients of Leishman stain? Do you remember? So, yeah, what are the materials required for Leishman stain? Components of Leishman stain. Take your class notes, check. This is the problem. What are the components of Leishman stain? What is the purpose of Leishman stain? Tell me, students, purpose of Leishman stain. I already discussed, I conducted quiz, I have all legal documents that I have covered all the things, but still you are unable to recall. So it's just ready-made studies. On the day you study and next day you are goodbye to the class. Now tell me, what is this Leishman stain? Purpose of Leishman stain. Tell me the purpose of Leishman stain. What is the purpose? Components. What are the components? Methylene blue and methylene blue and eosin. What is the purpose of your Leishman stain? Very good. That's the problem. What is the meaning of purpose?
It's use.
Uses. What is the use of Leishman stain? Yes, Taplo?
To stain the blood components. That's
To stain the blood cells.
to make them big.
Any more appropriate, more specific? Okay. Huh? Abhishek came close and Taplo also tried. First I finished both of them. In what lab test we will use this Leishman stain? In what his test we will use Leishman stain? Huh? Yeah. Moreover DLC, okay. And PBS you are saying, okay. I agree with both, right? So what is the purpose of Leishman stain now? To study the morphology of granulocytes, agranulocytes and other blood cells, maybe red blood cells, right? Usually for red blood cells we don't need any stain because red blood cells themselves are colorized. What is the color of RBC? You know, right? Yeah. So what is the purpose of Leishman? To study DLC actually, right? For studying both granulocytes and agranulocytes. So all these hematological called as another word. They will fall under one classification. What is that? All these stains together called as a single word, a term. Yesterday I said, yes, Pediatric. It starts with R. Romanowski stains. Okay, don't follow. Even though Tableau is in higher state, I mean he is sleeping, still he recalled what I said yesterday. So that means Tableau is a different candidate. He is a wise man. Yeah, we should appreciate Tableau first. See, very good. Yes. Romanowski stain. Romanowski stains. Very good. Romanowski stains. What is the unique feature of Romanowski stains? Manpreet will tell the answer. Now she might scold me in her head. Anyway. Yes, Manpreet. What is the unique feature of Romanowski stain? Do you remember? Yes? Any others? Very good. Abhishek given the answer even though he is absent yesterday. Very good. Everyone appreciate Abhishek. Very good. Yeah. Yes, tell me Abhishek now. Very good. All these stains are suspended in some alcohol base. They are mixed in alcohol. Very good. So all hematological stains are Romanowski stains. Keep in mind. Can you give few examples of Romanowski stains now? Leishman stain. Then. Very good. Right stain. Very good. Right stain. Ginsa stain. Ginsa stain. Then. HND stain. Yeah. Okay. HND stain actually fine. Moreover, HND is used in histopathology. Do you have histopathology subject in this semester? So yeah. So what is the principle of these stains, by the way? Can you tell me the principle in a nutshell?
Acidic
Very good. Acidic dye. Manpreet will tell the answer. Yes, Manpreet.
So जो acidic dye है वो basic से होगा और basic acidic.
Very good. Acidic dye will stain the basic part of the cell, whereas basic dye will stain the acidic part of the cell. Now give me the example of acidic stain. Very good. Who said eosin? Very good. Bicycle. Very good. Well done. Eosin. In HND, eosin is the acidic dye, whereas hematoxylin is a basic dye. These are basic dyes, I said. Keep in mind. Now, hematoxylin is also called as what stain? Wrong. Say shape. Reverse to clapping. What to do? Nuclear stain, right? Very good. Hematoxylin is called as nuclear stain. Very good. Nuclear stain. Then equivalent to eosin. Eosin is a cytoplasmic stain. Very good. Cytoplasmic stain. Okay. Very good. Then yesterday we also discussed a new concept. Actually, we already recalled initially. Indices. What is this blood indices? Tell me, students. Blood indices. What is this? What are the components of blood indices? MCV, MCH, MCCL, color index. Very good. What are the purpose of these four? Tell me, students. Let us write definition and formula and normal values. Okay. What is the definition of MCV? That is full form definition. Yeah. Very good. Mean corpuscular volume is the average volume of RBC. It is an average, not a single red blood cell, right? So what is the formula of MCV? PCV. Correct. Very good. PCV by RBC count into 10. What is the normal value range? Normal range of MCV? 87 to 92 fematoliters. Very good. F for small letter, L capital letter. Fematoliters. 78 to, yes, sorry. Very good here. Okay, 78 to 92 femtoliters. Now, increased MCV is called as increased Muscam. Macrocytic anemia. Increased is called as macrocytic, whereas decreased is called as microcytic. Very good. Then let us go with the MCH. What is this MCH? It is the amount of HB in single RBC. Very good. In single RBC is called as MCH. So what is the formula for MCH? HB by RBC into 10. Normal value of this one? 28 to 32 picograms. So increased MCH is called as hyperchromic anemia. Hyperchromic anemia, and decreased is called as hypochromic anemia. Very good. Then what is this MCHC? It is the HB concentration. Very good. In single RBC, in one RBC, in relation to its volume. Its volume. Very good. In relation to its volume. So, yeah, MCHC. What is the formula? Here it is HB by PCV, right? To my knowledge. Into 100. Very good. What is the normal value? 38, are you sure?
38.
Okay, 32 to 38 percentage. This is in percentage. Okay, very good. Then, what is this color index? It is a ratio between, it is a ratio between percentage of HB and percentage of RBC count. Am I correct? So, what is the formula for this one? HB percentage by RBC percentage into 100. Whatever you will get, that is your color index. Normal value by the way, 0.8 to 1.2 percentage. This is all about color index. Now, there is one more indices which is not described in a Shembulingam textbook, but that is present in another one. That is called as RDW. Even I need to cross check the formula and normal value, but just keep in mind, sometimes you will encounter this terminology called as RDW. So, red blood cell distribution width. Yes, Mr. Taplo.
You said when the MCH is increased, it's called hyperchromic anemia.
Yes.
Then when it's decreased, it's hyperchromic anemia.
Increased hyperchromic, decreased hyperchromic. Yeah. RDW, keep in mind, red cell distribution width, WIDTH, okay? Width, red cell distribution width. So, I forgot this formula, but the purpose of RDW is, if RDW is increased value, that indicates RBC might be enlarged. Okay, if it is small, it might be in a sickle cell or any other things. Okay. In your hematology theory, you might study inclusion bodies in the RBC. There are multiple inclusion bodies. Are you studying? Can you name any 4? May, Grunwald inclusion bodies. You forgot. In G6PD deficiency, inside the RBC, you will see a type of granules. Do you remember what are those? You didn't? My God, an entire unit 2 is dedicated to these things. Abnormal constituents within the RBC. Inclusion bodies. You didn't study. Your unit name is that, right? Chidak something.
Dole bodies and Chida.
Dole bodies.
NH19 deficiency.
G6PD deficiency. You will see a few examples. Very important topic actually. May Heglin, inclusion bodies. What are you doing, students? Painful. Anyway, this is recording and it looks like CU students, let it be like formal effect in this recording. Anyway, next one. I'm getting angry on you actually. Okay. Fine. Okay. What lab test you will perform among these to identify sickle cell anemia? What lab test you will perform? What are present in this here, okay, on this board? To identify sickle cell anemia. What lab test you will perform to diagnose, to confirm it is sickle cell anemia? Tell me, students.
Yes, sir. Yes, sir.
Yes, sir. Everyone clap for Tapolo first of all. Very good. If Tapolo really telling the justification, Tapolo is the best student in this entire batch. Yeah, Tapolo said for diagnosing sickle cell, he said yes, sir. Justify your statement, Mr. Tapolo. What happens?
Sir, I was thinking since the shape is...
Everyone stay quiet. He was thinking since the cell was C-shape.
It might... I don't remember my reason.
Anyway, continue. Try.
Yes, I can
Actually, he came with right conclusion. He is unable to explain this. See, since sickle cell was sickle shape, the rate of sedimentation is very high. So you will get very less CSR value compared to the normal individual. So getting a very less CSR value might indicate a fast sedimentation of red blood cell, which is due to abnormality of the shape. So that might be an indication. So in ESR, in sickle cell anemia, it will be reduced. Very good. What other tests you will perform to identify sickle cell anemia? On this board, yeah. Very good, very good. Highest histogram. You should have this critical thinking. You already know everything now, don't worry. So try to develop an answer. What other lab tests you will perform to identify sickle cell anemia? Yeah. Sickle cell anemia will be in sickle shape. How you will know whether cell is in sickle shape or not? What lab test you will do? PBS. Everyone clap for Biostatistics, but also shameful on others. It's a simple logical understanding. Just you will make a PBS, you will air dry the sphere and you will check under microscope. What is the problem in it? Yes, by saying why you didn't say the answer? Very bad. Anyway, PBS. Any other lab test? Yes, Arpita, tell me. She's smiling there. As such, she knows something else. Yes, Arpita. Yeah. Yes. What other lab test? I made you stand to tell answer. She's nicely standing and she's staring. Pink. Yeah. What other lab test Arpita will perform to identify the sickle cell? Okay, come with some smart answers, right? I think Tapolo want to answer. Yes, Tapolo.
TRBC. TRBC.
TRBC. Oh, that is a very good actually. I will consider. He's trying to say that the TRBC, he will take a drop of blood, add with the Heinz and keep under newborn. So you are going with the microscopy where there is a possibility of sickle cells can be encountered. Very good. Credit given to Tapolo only, not Arpita. You can sit down there. Very good, Tapolo. TRBC also can be done to identify. Everyone clap for Tapolo, by the way. Jealous people. Yes. Very good, Tapolo. Tapolo is most logical understanding rational being in this class. No, hyper being. See, by saying you didn't answer, I'm not proud of you. You don't know. Very good. Any other lab test? RDW. Everyone clap for Ria now. Very good. this class now. Because RTW just now we discussed. Very good. RTW. In RTW you might get abnormal value. It might be decreased. Very good. Red cell distribution built of the red blood cell. Very good. Any other lab test you will perform? Huh? See this, I will give you. CPC is a hyperterm for all lab tests. That's not an answer. That's not a specific answer, by the way. Yes, Miss Chantal. What? HB. Okay. So in single shape, HB definitely will be reduced, or surface area reduced, so HB might be decreased. Okay, I will give you credit. Everyone clap for Chantal also. Very good. Okay. Now you are coming with good answers. HB might be reduced in sickle cell because surface area reduced. Chances are there. Very good, Chantal. Any more other reasons? Huh? Everyone clap for this very good. MCV might be reduced because it is the volume of the red blood cell. Overall, in average, volume might be reduced. Very good. Very good. Any other reasons? Now I will give you some specific tests actually. These are okay, I agree with this. Some other tests include sickle cell solubility test. There is something called sickle cell solubility test. Sickle cell solubility test. So what they are trying to say was, if you subject to a hypotonic solution, do you know the concept of hypo, hyper and isotonic solutions?
Yes.
What happens if you suspend RBC in a hypotonic solution? Shrink. Oh, you forgot this concept. This is very interesting concept. I will let you know that. What is this hypo, hyper and isotonic? Very interesting concept. So, do you know the concept of osmosis?
Yes.
What is the definition of osmosis? Yeah, very good. Movement of water in a semi-permeable membrane might be, concentration gradients might be there. So, in that analogy, give me one example here. I have taken a slice of potato. This is a potato slice. Okay. I kept this slice in contact with the water. Water is up to top. Okay. This is water. Then I kept a small, well in the potato, a dip. Okay, a small hole in the potato. Now in this potato, I kept a sugar solution, sugar syrup. Now tell me the movement of water in this situation. Gravity is always down, force of gravity is towards bottom. Whether water will move upside or sugar solution comes down, what happens here? What are you thinking? Water will go upside. Is it possible? Anti-gravity movement. Is it possible? Yeah, correct. That is the law of osmosis. Not law, the concept of osmosis. Water always moves. Movement of water. Movement of water is always from low concentration area to the high concentration area. Water always moves from low concentration area to the high concentration area. This is the basic fundamental concept of osmosis. Tapolo was confused somewhere. Yes, Tapolo?
I got lost after you explained
Huh?
about. I got lost after you explained about.
You got lost here. Actually, this symbol was a concentration symbol. CYMCC.
No, sir. After you explaining about
Here,
making the
see
example.
Tapolo. Listen. Simple. I said this statement, right? Water moves from low concentration to high concentration. Let us see in this system. Here water was a pure water, a low concentrated area, and here it was a high concentrated. Water was mixed with some sugar, so the concentration was high. So let us see the movement of water here. As for the statement, water will always move from low concentration area to the high concentration. So in this, water will move upside from low concentration area to the high concentration area. Why this concept was important, I will tell you. I was initially surprised when I saw this movie first time. I forgot the movie name. I was unable to recall. Jackie Chan movie. It's a Jackie Chan movie. So what happens in this movie was commander, I guess. Commander or similar word I know. So what happened in this movie was a person, they are going into the desert, bike ride in the desert, and one of the person collapsed in the desert. So our Jackie Chan came, and what he did was, one girl also came, I think that person's girlfriend. So what happened? He immediately took a coconut, tender coconut. He took the pipe, a pipe from the this spare parts from the jeep, and he took the bike puncture, needle, this basketball needle, for basketball to give there is a small needle. Anyway, simply there is a needle. So he connected it to the pipe. He injected needle into the vein of this person, and he kept this pipe directly in the coconut water. And he started giving saline. It's a saline given to the patient. So what was my thought was, if you are giving water, I know coconut is a water. So he is literally killing the patient. If you suspend red blood cell in water, what happens? Admissible lies. But that worked out. In that movie, the coconut water saved that person. What happened with this scenario? You got my point. He directly injected coconut water into the vein. Is that a safe game or not? What is your thoughts on giving coconut water directly into the vein? We might die, right? Yeah. Now, to understand what happened in that movie, you should understand this hypo, iso, and hypertonic solution. Let us see here. Let me keep that over here. See this concept. Actually, these are very interesting. Let us assume there are three water classes. There are three water classes. Okay. Then I'm going to suspend a ball. Assume this ball was red blood cell actually. Okay. Now, the salts in this was, for example, 100 grams. 100 grams of salt was present inside the red blood cell. Okay, let us see. I suspended 100 grams of, I dissolved 100 grams of salt in this glass. Equal amount of water is there. Keep in mind 50 ml of water, for example, or 100 ml of water for ease of conversions. 100 ml of water in 3 glasses. In this glass, I kept 100 grams of salt. Then I suspended my red blood cell. Nothing happened. The number of solutes in the water and in the cell was same. Nothing happened. This glass, this water is called as isotonic water. This is called as isotonic. Isotonic for this red blood cell. Isotonic water. Okay, isotonic solution. Now let us see in a different situation. In this glass, I kept only 50 grams of NaCl, salt. I added only 50 grams of salt in this water. Got my point? I added 50 grams of salt in this water. Let us see of suspending red blood cell in this. Red blood cell has 100 grams and our water has 50 grams. What will be the movement of water in this? As per the statement. See here. Actually, my brother is going to say it. He said he can't contact me for next 10 days. Anyway, he does not bother with saying us. Anyway, yeah. So where am I? This one. 50 grams of salt suspended in water with red blood cell containing 100 grams. So what will be the movement of water in this system? What is our statement? Water always moves from low concentration area to the high concentration area. So here, what's happening? Low concentration is here and high concentration is inside the red blood cell. What will be the movement now? Now the water will start moving inside the red blood cell. Am I correct? So red blood cell will be swollen. Such solutions are called as hypotonic solution. This solution is called hypotonic solution. If you suspend a cell in a hypotonic solution, the cell will expand. It will swollen because the water will gush into the cell, rush into the cell. Got it? Then let us see the third scenario. Here I added 200 grams of salt in this 100 ml of water and I suspended my 100 grams of cell here. 100 here, 200 here. What will be the movement of water now? Water always moves from low concentration to high concentration. Now, water present in the cell will come outside. Low concentration area to the high concentration. Now the cell will become small. Cell will shrink. These solutions are called as hypertonic. Hypertonic solutions. Is it clear? So what happens to the cell if you suspend it in the hypertonic solution? It will shrink. Now the concept of sickle cell dissolubility test was, we know that an ideal biconcave cell, if we are subjecting it to the hypotonic solutions, that means maybe this is 100% salted, here 90%, 80%, 70, 60, and 50. See, a healthy biconcave can able to tolerate up to 60% of hypotonic exposure. A good red blood cell can able to withstand up to 60% of swelling. But a sickle cell will be lysed just by subjecting to 90% hypotonic solution. So we will simply make a hypotonic solution and we will suspend 90% hypotonic solution and we will suspend the RBC. If it is lysed, definitely that is sickle cell. Because sickle cell cannot tolerate hypotonic conditions because it is already very fragile. A simple bulging will lyse the red blood cell. Now understood, right? So if you are still thinking these things, the practical applications are many things for this one. Just imagine a seawater fish. Seawater fish will only survive in seawater but not in fresh water. Now you understood the reason, right? So if you suspend a seawater fish in fresh water, inside the fish, the moment each and every cell will be bulged and fish will die. Can you able to understand the pain of the fish if you subject it to the hypotonic? Very painful death. You know, even the brain of the fish will be lysed. Same happens if you suspend a freshwater fish to a salinity. Okay. Yeah. If you want to kill the plants, just pour some salt water to the roots. Now you understood, right? What happens? Salt water will disbalance the gradient, osmotic gradient. Now the plant either it will dehydrate or this one. Now I also came to the concept of dehydration. If you drink too much salt, you will get dehydrated. Can you guess the reason now? If you had too much, if your plasma has too much salts, now the cell to plasma In plasma, 110% of salt, and in cell 100%. Cell will shrink now from low concentration to high concentration, leading to a dehydration, which is happened due to a chemical dehydration. Understood? Understood. Now, see, this concept was so beautiful that yes, is always saying beautiful something which is not at all understandable. Anyway, now see, ancient people 10,000 years ago understood the concept of dehydration or these things. I will give you one best example. How many of you know about mummies? You know mummies, right? How mummy will work? Not M-U-M-M-Y, M-U-M-M-I-E. Yeah. Mummy is a preserved dead body. Am I correct? Yes. Preserved dead body. Usually, if a dead body died, if a dead body was here, it will decompose. But a mummy won't decompose, right? It is preserved. So, whenever I'm saying this mummies, the students will have a disgusting faces. Are dead bodies, preserved dead bodies. I just want to give you one best example. Okay? Are you ready to eat a dead body, a mummy? You won't eat, right? Okay, now there will be a debate. Vegetarians and non-vegetarians. Okay? What about non-vegetarians? Are you ready to eat a mummy? You won't eat, right? Yeah. Now listen then. How many of you ate dry fish? That is mummy, right? Dry fish is a fish mummy. Then why you say, when I say Egyptian mummy, you kept a disgusted face. But when I say dry fish, you are happy with it. Oh, then vegetarians are coming here. How many of you had a mango pickle? Yeah, mango pickle is mango mummy only. You suspended that in the salt. First you will apply salt to it, right? You are removing water from the mango. So literally you desecrated the mango, so it won't decompose. Then moreover you suspended it in the oil and another mordant where it will protect it from external environment. Pickles are mummy equivalent for vegetarians, and dry fish is mummy equivalent for non-vegetarians. See, our ancient people understood the concepts of preservation. That is called dry preservation. You are using salt. So in mummification, what they will do? They will remove this intestine, everything. They will keep salt in the body. And these people thought that, yeah. I want to tell you one best, fun fact. What is the most underrated organ in our body? But it is the most important organ. You know what is that? Brain actually. What these Egyptians thought was, if you saw a beautiful boy or girls, a beautiful handsome boy, first what will be the expression? You will get some heart attack, right? So yeah, see, you are giving credit to the heart. So Egyptians also thought same thing. Maybe emotions preserved in heart, sad or everything. So they thought that memories are in the heart and they preserved heart in a jar separately. And what they did, there is some stupid, jelly substance. They removed this brain. They discarded the brain. So that's why brain was underrated organ. It is actually the brain that is giving us the emotions, right? But they thought, okay, heart rate increased. Heart was the center of memories. Yeah, because there is no medicine at that time. Why I said this heart problem? Yeah, mummies, yeah. They preserve hearts but not the brains. Yeah. Yeah, all this came because of this culprit, sickle cell anemia. Yes. Fine. So now, you understood why you should not give mineral water as a saline water. Saline water has some appropriate salinity or solutes equivalent to the plasma solutes. Okay, that will act as a plasma expander. next another interesting thing. If you can't give, salinity through the vein, then give similar salt concentration orally, and that is called as oral rehydration solution, ORS. And ORS always says one important, instruction on the packet. What is that? This packet must be dissolved in 1 liter of solution. If you are too smart and you are only keeping half liter with a complete ORS, you are not making that isotonic solution. You are making either hypertonic. If you are not using 1 liter, if you are using more than 1 liter, that becomes a hypotonic. Now you understood the science behind ORS, right? When they said 1 liter, it should be 1 liter. Don't be over smart. Okay. What else I can discuss? I have 1 more hour. Any other things you want to discuss? Fun facts. These three they want to leave. They want to write their assignments. Yes. Next. Okay. If Mariam has allergic problem, what lab test she will perform to diagnose her condition? We suspected Mariam has some allergic condition, okay? What hematology lab test you will perform? DLC, very good. In DLC, what value you will look? What count you will check in DLC? Eosinophil count. If eosinophil count was more, definitely that indicates our Mariam has some allergic issue. Very good. Why they are leaving polyclonal? Okay. Next one. If Ria has a parasitic infection, what lab test she will perform? DLC. What? AEC. Very good. What is the full form of AEC? Next one. Okay. If a person has TB, what lab test you will perform? What is the full form of ESR? What are the methods of ESR? What is the normal values of ESR in males and females? In Wester's method. Yes? Up to 5 to 15 in females, 11, around up to 11 will be in males, okay? Okay, very good. What is the difference between grouping and typing? Grouping is ABO and typing is positive and negative, very good. Who discovered archetyping? Alexander S. Weiner, right? Okay, very good. Then, what is the concept of Bombay blood group? Do you know what is Bombay blood group? Do I discuss with you? No, and actually the absence of H antigen, keep in mind. In the Viva, if they are asking, absence of H antigen is called as Bombay blood group. Okay. Or anti-H antibodies. Anti-H antibodies or absence of H antigen. Okay. What is Karl-Steiner law? You remember? What is Karl-Steiner law? Yes, tell me. If a particular agglutinin present on the surface of RBC, the corresponding agglutinin will be absent. You remember?
Yes.
Then, another transfusion concept. Can a positive person receive negative blood?
Yes.
Very good. Can a negative person receive a positive blood?
No.
Very good. What is the reason? Yeah. sensitization. Negative person, when he exposed to positive blood, he will get sensitized to positive and he will develop antibodies against positive antigens. The second encounter will be game over. Yeah. Next one. What is this erythroblastosis fetalis? What is this concept called erythroblastosis fetalis? Yes, Jeriel. Jeriel, you don't have specs previously, right? Yes. Plasma ratio not plasma ratio. What is erythroblastosis fetalis? Yes. Arpita, please tell the answer. Stand up. Everyone, appreciate it. Yes, now tell the answer. You already got appreciation. Now you must be correct.
Sir, the mother is having a negative blood and the child is having positive because of sensitization.
The second the baby will get the complication. Everyone again appreciate that. Very good. Multiple blood clots in the blood vessels is called as what condition?
Thrombosis.
DIC. Thrombosis, DIC. Disseminated intravascular coagulation. In case of DIC, PT will increase or BT will increase? In case of DIC, what lab test will increase? PT. Oh, she went even further. Prothrombin time. Why PT? PT is extrinsic. APTT is intrinsic. APTT should increase. We are confused. APTT will increase. PT is extrinsic. Clotting time will increase. Clotting time will increase. Oh, you follow those concepts. Absence of 2B is called as what disease? On the platelet. Absence of glycoprotein 2B leads to a condition called as Bernard-Solier syndrome. You forgot? Okay. Breda, Miss Breda. Yes, sir.
Your passport and tomorrow is pending.
Your passport details pending. Yes. Next one. Factor VIII deficiency leads to what disease? A or B? A. 9 deficiency? 10 deficiency? Oh. 11 deficiency? There is no D. Okay. How many? They want to leave. Okay. How many chains present to the hemoglobin? 4. What are they? Defect in any of these chains leads to what condition? Thalassemia. Thalassemia beta or minor and major. Very good. What disease is called as Cooley's anemia? Cooley's anemia. Actually, there is a scientist who discovered thalassemia. His name is Cooley something. So it is thalassemia is also called as Cooley's anemia. If you might study the integrity of that.
You are 93, 13, 29, 32, 36, 54, 55, 76, 87, 113, 14, 8, 201.
Any one of these UIDs? Yes, you can go.
Wait. I shared one link in your official group, MLT International Data. Students are, you have to fill it. Please students, please.
Fill the form, okay?
93, you added 93, 13, 29, 32, 26, 54, 55, 76, 87, 113, 114 and 8201. Okay? Please update and then fill the form of the MLT International Student Data. Okay, fill it. Please.
Fill MLT international data, okay? All these mentioned inquiries. Yeah, I think these are international standards. Yes, sir. Alright. Alright students, now I think I can finish this class now.